Let's plot this complex number 16 minus 16i on the complex plane. So the real part of this complex number is 16. This is the real part, and negative 16, and this is the imaginary part. So we have to look out for the real part 16, which is this. I can put this line, and the imaginary part is negative 16. So I'm just dropping a line across. So this is the point 16 minus 16i on the complex plane. Okay, so now let's rewrite the complex number in polar form. Remember that if z equals x plus iy, this is in rectangular form. The polar form of this complex number is written as z equals r times cos theta plus I sine theta. And this is the polar form of the above complex number. So we have to determine r is given by this formula, that is r is the magnitude of the complex number, which is square root of x squared plus y squared, and then the argument theta, this equals tan inverse of y over x. So we will utilize these two formula and write down this complex number in the polar form. So let's determine r from this complex number. So consider this as x and negative 16 as y. So therefore we can find r using the formula, which is under the root of x squared, that is 16 squared, plus y squared, which is negative 16 squared. So let's determine this. 16 square is 256, and the negative 16 square, and this is also 256, and we should take the square root. I'm not going to sum this up. I'm going to write this sum as 256 times 2. Basically, it is 2 times of 256. So now we can rewrite this radical as under the root of 256 times under the root of 2. We know the square root of 256 is 16. So therefore this becomes 16 root 2. So we found the r as 16 root 2. Now let's determine the theta using the formula, that is theta equals tan inverse of y over x. We have y equals negative 16 and x equals positive 16. So therefore this becomes tan inverse of negative 16 over 16. So this equals tan inverse of negative 16 over 16 is negative 1, and tan inverse of negative 1 is negative pi by 4. So we can say that this equals negative pi by 4. So we found the theta equals negative pi by 4, and this means we can write down the polar form of the complex number, that is polar form is r times of r is 16 root 2. So I put 16 root 2 times cos theta, theta is negative pi by 4, plus I times of sine theta, theta is negative pi by 4. So this is the polar form of the given complex number. We can also write its exponential form using the formula, that is z equals r times e raised to the power of I theta. This is the exponential form of the complex number. This is exponential form. So we write down the exponential form of the complex number is r times r is 16 root 2, e raised to the power of I times of theta is negative pi by 4. So this is basically 16 root 2 e raised to the power of negative I pi by 4. And this is the exponential form of the given complex number.